Good evening, dear students. Welcome back to second PUC online classes. Students, in last class, in yesterday class, we learned about the spectral series of an hydrogen atom, that is a Lyman series, Balmer series, Parsons series, bracket series, and a Fund series. Okay. In today's class, we discussing about the empirical formula for that 5 spectral series, Lyman, Balmer, Parsons, bracket, Fund series, and after that Bohr's atomic model, then Bohr's radius. Okay, this one is a very important for 2 marks. Write the empirical formula. Okay, I'm going to write question here. Write the empirical formula for wave number of the following spectral series. For wave number of the 5 spectral series. Okay, dear students, this one is a very important question for your theory and CET. Write the empirical formula for the wave number of the 5 spectral series. Okay, first one spectral series, that is the Lyman series. Lyman series, its empirical formula 1 divided by lambda is equal to R into 1 divided by 1 square minus 1 divided by n square, where n is equal to 2, 3, 4 dash dash dash. Okay, here 1 divided by lambda is equal to R. R we call as Rydberg constant, and 1 divided by 1 square means here n1 square. In the place of n square, that is the first series, that is the Lyman series. Minus 1 divided by n2 square. In the place of n2 is n is there. N means 2, 3, 4. Okay, like that. Okay, this one is the first state and these are the excited state. Here electron jumps from higher orbit to first orbit, fourth to first, third to first, second to first. When electron jumps from higher orbit to the first orbit, that series we call as Lyman series. Already know that. Okay, this one is a empirical formula for a Lyman series. And next, second one Balmer series. Its empirical formula 1 divided by lambda is equal to R into 1 divided by second orbit, that is a 2 square, minus 1 divided by n square, where n is equal to, this one is the second orbit now, its higher orbits 3, 4, 5 dash 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 dash. When electron jumps from higher orbit to second orbit, that is called as Balmer series. Its empirical formula 1 divided by lambda is equal to R into 1 divided by 2 square minus 1 divided by n square. And next, third one, Parsons series. Okay, Next one is a Poisson series. 1 divided by lambda is equal to r into 1 divided by, this one is the third orbit, that is a 3 square minus 1 divided by n square. Here where n is equal to higher orbits, third orbit, it's higher orbit 4, 5, 6 dash dash dash. When electron jumps from fifth orbit to third orbit, sixth orbit to third orbit, or fourth orbit to third orbit, that one you call as Poisson series. Next one, fourth one orbit, okay, that one is the bracket series. Bracket series. Bracket series. Okay, bracket series. 1 divided by lambda is equal to r into 1 divided by, this one is the fourth orbit, 4 square minus 1 divided by n square, where n is equal to 5, 6, 7 dash dash. When electron jumps from higher orbit to the fourth orbit, that one we call as bracket series. Next one, fifth one orbit, fund series or P-fund series. P-fund series. When electrons jump from higher orbit to the fifth orbit, that is the 1 divided by lambda is equal to r into 1 divided by, that is the fifth orbit, 5 square minus 1 divided by n square. Here where n is equal to 6, 7, 8 dash dash dash. When electron jumps from higher orbit to the fifth orbit, that is called as fund series. Okay, and where here r we call as Rydberg constant. r ಅನ್ನೋದೇನಿದೆ ಇಲ್ಲಿ Rydberg constant ಅಂತ ಕರಿತೀವಿ. ಆಲ್ರೆಡಿ ನೀವು ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಓದಿರಿ ಇದ್ರ ಬಗ್ಗೆ. Rydberg constant. Okay, and lambda it is called as wavelength. Okay, and 1 divided by lambda you call as wave number, nu bar. Okay, reciprocal of wavelength you call as wave number. Okay, up to here I explained empirical formula for that 5 series. The next